All right, we're back again for another great video talking about those transformations of quadratics on today. Let's get into it. So we've been talking about in the past two lessons here over this topic that the parent function is at that home base where f of x is equals to x squared, which is the same thing as y equals to x squared as well. So when we're talking about this, just a quick recap here. We talked about our different types of transformations, going up or down, left or right, reflection or no reflection, and compressing or stretching. In this here example, we can see that from vertex to vertex, we went to the right and we also went up. Notice how there is no number in front of our parentheses here for our blue line. So that means we did not compress or stretch. So we're still good to go. It's the same exact quadratic shape. All right, for this one, an example, there was a lot that happened here. Multiple things. We can see when we went from our vertex to our other vertex that we went up. We also went to the left. And if you notice, we compressed because our new function is a lot more smaller or narrower than our original function. We also went from happy to sad. So yes, we do see some reflection here. All right, so now we're going to put everything all together and we're going to locate, well, what is the vertex of our new formula here, or our new equation rather. So if we're starting at f of x equals to x squared, our new equation is g of x equals, and we're just going to put an f parentheses x minus 4, just like they gave us. Okay, so that's why it's super important that we always begin with f of x equals to, because if I put y equals to, you see that caution sign, it doesn't help us. So we're going to instead use f of x, so it will help us identify the two different functions. Remember our home button, and notice how it highlighted also in our Desmos, the x squared here. That's our home button. So we know where we're starting at. But the question in our first one asks, what is the vertex of G? Well, our vertex of G is right here, is at 4, 0. So let's go ahead and write down our vertex here. So we're going to write down our new vertex of G is at 4, 0. So we're going to start by drawing in red. Well, I'll draw it in red. I'm drawing in red our parent function. So go ahead and add our parent function, which is f of x. And I'm just going to put it as f, right? Then my new function, I'll do it in green today, is right here. And I didn't mean to draw that more skinnier on purpose or anything. But this is going to be G. And we're going to notate that here at G, that is our vertex, which is at 4, 0. So now we have that. So now it's time for us to describe, well, what's happening here at G. We did not go up or down, but we did go to the right. So we're going to circle right. We stayed happy, so there was no reflection here. So we're going to go ahead and circle no reflection at all. And we stayed the same because there was no number in front of our parentheses. F is not a number, so that does not count. Since there's no number, that's how we know our quadratic stayed the exact same size. All right, you give one a try. Okay, I know you guys killed it on that last one. Let's look at this next example. So now we have f of x equals to x squared when g of x equals to negative 3f. So now we know we're going to have something happening here. Negative 3f with x plus 3 plus 7. Okay, and of course, we're going to write it exactly how they have it here in our function. As we can see, we're going from vertex to vertex, and there's multiple things that happen here. We're going up and we're going to go to the left. So let's go ahead and circle that right now. We're going up. We're going to the left. I went from happy to sad. So there was a reflection. And I got skinnier. And how did we know we got skinnier? Because that number 3 is our A in front of our parentheses. So that means that we got skinnier. And skinnier just means we compressed. So with A asks us, well, what is the vertex of G? As we can see, our vertex is right here at -3, 7. So what I'm going to do now is I'm going to draw with my red my parent function to support our answer. So this is our starting point. And in green, this is what we end up looking like. Again, it does not have to be perfect. It is just a sketch. Awesome. Now you try. All right, so from here forward, I know you guys are going to kill it. You guys have some practice problems to do. I'll see you guys for the next video.